let's take a look at A here. We have the square root of 24x squared over top of the square root of 3x. Okay, now remember my steps worked as long as there was no adding and subtracting. And there is no adding and subtracting here. Okay, so then I can use my steps. I can reduce vertically. There is nothing out front here to reduce. Do you see that? There's no like 4 on the top with an 8 on the bottom. That could be a reduced fraction. So I'm fine. It's a 1 over 1, which doesn't simplify any more than that. Okay? Now I can reduce inside. When I reduce inside, so I'm still on step 1, but I'm reducing the radicands. I can reduce the 3 and the 24 and the x squared with the x, but they stay under the radicals, okay? So 24 over 3, what does that reduce to be? Or does it actually divide out? What do you get? You get 8, or in other words, it's 8 over 1, okay? But either way, I'm looking at an 8, and it would be an 8 in my numerator, okay? Because it would technically be an 8 over 1, right? Okay? Now, what about the x squared over x? How does that reduce? You just get an x. Is that left over x in the numerator or in the denominator when we were dealing with an x squared at the top and an x in the bottom? It'd be left over in the numerator, right? So it stays in the numerator. And I actually have nothing in my denominator, so this question's actually done. Okay? Except for, now I need to simplify it. So the dividing part is done. Okay? So step 2 is reduce horizontally, which we've been practicing in 5.1. What perfect square fits into 8? 4. Okay, so this has a square root 4. The leftover is a square root 2, and x is also just a leftover. The square root of 4 is 2, so that can come out as just a 2 itself, and then these two can combine back together. So the answer is going to be 2 square root 2x. And x still has to be greater than or equal to 0, and x is an element of reals. Actually, what did they have on it? Why am I wrong? Oh, they are wrong. Why are they wrong? You can't have it be equal to 0. Even though it reduces, when you look down at my answer here, I could have a 0. But look back to the original. If I actually plugged in a 0, do you see how it would make my denominator 0? So they're actually wrong on this one. It should just be greater than 0. And even though mine looks this way, it's just a different version of it, but I have to go with the original rules. So it's going to be greater than 0. Okay, so we've done step 1. We did step 2. Step 3 is rationalize the denominator. But we don't even have a denominator, so we're done that question. Okay?